Okay, good morning everyone. Before entering to the topic, let me introduce myself. Bhuvaneshwar. Currently, I'm pursuing a BTech undergraduate from Institute of Aeronautical Engineering from the Department of Computer Science and Engineering. This is my this is my about myself. This whole PPT is from the subject Computer Organization Architecture. Uh, in this whole PPT, we are going to talk about the computer only memory architecture. As we know, there are various memory architectures. In this, now we are going to be briefly discuss about the going to be focus on the computer only memory architecture. Yeah, now we are entering into the topic. See, let us see shared memory MP taxonomy. First, as we know, there can be a single memory, multiprocessor, shared memory, multiprocessors. Let us categorize them now. See, we can first we can see now. Yeah, now first we can see that all process take this. Wait. Yeah, now yeah, here you can see first is single memory, usually UMA. Like a single memory means let me show you. Yeah, suppose there will be a there will be a single processor and the single memory here. The single memory and single processor, there will single processor and single CPU and single memory. If you want to fetch any instruction directly, you can fetch from this memory. There won't be any extra memory for there won't be any extra added memory for this here. It will be directly connected here. Like this is single memory, which you can, if you want to describe briefly. Now let us see what is meant by distributed memory. Distributed memory in the sense same like in general says the like memory was allocated or split into various memories. Like now it is distributed. Let us now see what does it mean. Suppose this is a CPU or processor. It want to execute. There will be a bus or something connected. Now there will be various memories which were connected. It can be any number of memories. Like at certain time it can access here, it can access here, it can after some time it can access from anywhere which your data was stored. Like you can describe it briefly as a distributed memory. This is the brief description about the distributed memory. Now cache only memory. What does it mean by cache only? Basically cache memory means, suppose suppose see, if this is the CPU. If first it want to fetch the data, first it will search into the cache memory. Cache memory in the sense, most frequently executed instructions were stored in the cache memory. Even the cache memory will be subcategorized into various level. It will be first level, second level, third level, fourth level. After like later the main memory will be connected here. First the instruction will be first searched in here in the first level of cache memory. If doesn't fetched here, like doesn't occurred here, it will go into second cache memory, second level of cache memory. Next it will go and search in third level of cache memory. Next it will be fourth level, and if doesn't it find in the cache memory, it will go into the main memory, and it will fetch the memory and it will get executed. This is the going to be basic structure and basic the concept of cache memory, how it is going to be worked. You can think of it as wait, let me. Yeah, you can think it of an cache memory as an intermediate between the main memory and the CPU. Like it acts as intermediate between the main memory and the CPU. There will be various buses or control signals which use to control the cache memory, where we are going to discuss about it in the further slides. This is the brief discussion about this. Whole brief discussion about this graph, this flow chart, like whereas how it's single memory, how it was going to work with distributed memory, and how it's going to work for cache only memory. Now let us see what is meant by unified memory architecture. Yeah, unified memory architecture, UMA. Unified architecture means there will be a memory which was connected into the network in the sense we can use an address which we can treat this as bus. It will subcategorize into the cache which will connect directly into the cache memory. Each and every cache memory has a sub processor. Each and like there can be any number of here the dot indicates n number of, like it can be any, it can vary from n to 1 to n, which were connected to the cache is connected to the processor. This is going to be the structure of an unified memory architecture, which shortly known as UMA. Here all processors take the same time to reach the memory. Here, yeah, if this, like see, this processor was first it will search in the cache, it fetch in the memory. This processor will, let me clear, yeah, first this cache will search in the if the processor want to fetch the instruction, it will search in the cache. It doesn't get it, it will execute in the memory via bus. This, if this processor want, it will first fetch in the cache. If doesn't take, it will, this processor take the same time to reach it. See, you can see this processor and this processor will take the same time to reach the memory. The network could be bus or here we should network, right? Network can be bus or factory. There could be one more, they can be one or more memory units. Here it can be could be it can be one or more memory units. Like even there are more than one, the time going to the same. So that's why we call it as a unified network, because the level here cache coherency is usually through Snoopy protocols for bus based architectures. Now let us see what does it mean by non-uniform memory architectures. Non-uniform, like before, there used to be a one memory connected before the network. If this processor want to fetch the instruction, uh, the time here it will be the same. The time it will be the same for everything. But here if this here, but if here every cache will be connected to separate memory. If it doesn't, if it want to fetch the from here, that will, due to the different architecture from here to here, it makes take n1 time and it won't take n2 time, where n1 may be equal to n2, but most of the case it won't be equal. That's why the time won't be same here. That's why we call it an non-uniform memory architecture, NUMA. Here the time of the fetching the structure would be saved. That's why we used to call it an non-uniform memory architecture. Here the network can be anything like butterfly, mesh, torus, etc. Scales well up to 1000 processor. Here the even you can take the 1000 microprocessor, it will scale up to the same. Cache coherence is usually maintained through director based protocols. Partitioning of data is static and split. Here the data was, we should, if we want to divide the data, it should be it is static, like it won't be dynamic. The processor won't dynamically do it. The programmers, we should do it statically, and it should be explicit. Unless and until you explicitly partition the data, it won't divide the data partition. There should be an expert to monitor the partition of the data. Now let us see what does it mean by cache only memory architecture, which is our hot topic, main topic of the whole PPT. Cache only memory architecture, simply called as COMA. Here there won't be any main memory kind of thing. There just be a cache memory which is connected to the processor, cache memory connected to the processor, and each and every kind was subcategory into attraction memory and attraction memory, and there was further attached into the network. The data partition is dynamic and implicit. Here, when compared to the ununiform, it will be quite opposite. The data partitioning is dynamic and implicit. Attraction memory acts as a large cache for, like see here, attraction memory acts as a large cache for processor. Like it is on one when compared to the cache memory, the memory space in the attraction memory will be the more. As you can see, yeah. Also, otherwise you can think it of like an see. You can think, suppose this is the CPU. It fetched from cache memory. Attraction memory was an extension of cache memory. Like it will be the data will be, you can store more data in the attraction memory than the cache memory. Like you can think as a last level of an cache memory. Even you can think it of like data partitioning is dynamic and implicit. Attraction memory acts as a large cache of processor. Attraction memory can hold data that the processor will never access. Think of a distributed file system. USP can give UMA like performance on NUMA stack. Like it can give the performance like a unified memory access, like performance in even if you use this kind of architecture, it can even give the best performance of UMA unified memory architecture, like performance on non-uniform memory architectures. Now COMA addressing issue. First addressing will be item. Similar to the cache line, item is the coherence unit moved around. Next it will be memory references. Virtual address item identifier. Item identifier space is logically the same as a physical address space, but there is permanent mapping. Like same as memory reference, virtual address will be item identifier. Item identifier space is logically the same as physical address space, but there is no permanent mapping here. Next, item migration improves the efficiency here. Next, program only has to make sure logically holds data. Partitioning can be dynamic. Now let us see what does the data diffusion machine mean. Data diffusion machine, DDM, shortly known as DDM. Data diffusion is an hierarchical structure implementing the COMA. Like DDM is, you can think it of an bus kind of thing. DDM is in a bus which used to implement the cache only memory architecture. DDM is a hierarchical structure. It can even you can think it as single bus. You can take multi-level bus or a single bus, or even you can take a hierarchical bus. Uses DDM bus. Attraction memory communicates with attraction memory here communicates with processor using the below protocols, like attraction memory which we discussed above. Using the protocol, it will communicate. Next, DDM bus using the above protocol Snoopy. At the topmost level, node use top protocol. Now let us see what does it mean by architecture of a single architecture of how a single bus architecture will be there in the DDM bus. First, there will be an attraction memory. As you can see on my screen, there will be an attraction memory. Attraction memory will be directly connected to DDMS bus, which we discussed. There will be a direct interlink between the processor and the attraction memory. Now, to the controller and processor, they will be sending control signals from the bus and receive the bus. And attraction bus will select the various local using top protocol, and at last you are going to fetch the instruction which you were needed. Then it gives rise, then at last after passing unit, it gives the instruction which you need from the memory. This is going to be the architecture of an single bus DDM. Now let us see what does it mean by single bus DDM protocol. An item can in one of the 7 states, like as we discussed before. Item can be any one of the following case. First, it can be invalid. Invalid in the sense item or instruction doesn't get executed. Like it will if after getting it won't do anything. That is the case where invalid means. Next, it could be exclusive. Exclusive means exclusive operation will be performed if both the if items in which instruction reach the true, or either any one of the true, it will be executed. Otherwise, it won't be. Next, it will be shared item. Next, it will be reading item. Next, it will be waiting. Next, it will be reading and waiting. The two operations will be performed at a time: reading and waiting. At last, it would be answering in the sense answering, you can think of like just giving an output needed by the certain kind of bus. Later, let me erase this. Now the bus carries the following transactions. The DDM bus which we discussed can carry among this instructions, these 6 instructions which I am going to discuss now. It can perform arrays, like it can clear the data on the bus. Next, it can perform exclusive operation. Next, it can read, like it can take read the information on the data, and it can store on the memory on the cache, like it can be perform a read operation. Next, it can be data, like it can write the data on there. And next, it will be an inject operation. Like inject operation almost equal to write operation there. Next it can be out operation. Out operation in the sense giving out the data which was present previously in there. These are the main operation which you can think of on the bus carries the following, like the DDM bus can perform the following operations on the cache only memory. Now let us see, let us trace the flowchart of how the DDM bus protocol works. First, see, there will be a memory operation. Memory operation will be subcategorized into read, write, and replace. Now, read is going to subcategorize into exclusive or shared, and here write is going to be again exclusive. Here the replacement will be shared. Like read can be performed both exclusive and shared. Write can perform exclusive only. Replace can perform the shared. Now from there, exclusive or shared can be taken as S, can be categorized as S or no. S can be treated as read or no bus transaction. No means issue bus write. Now again exclusive can be S or no operation. S can be write no bus in transaction, and no shared. Shared can be again further classified into S or no. S means issue output. No means don't issue inject. That's the difference between S and no here. Again further in the memory operation, after write operation was completed, then exclusive operation, if S and no, if you further categorize into no, the no can be further calculated into S or no. If the instruction is S, issue erase and write. If instruction is no, then issue bus the transaction and go to the reading waiting. This is going to the overall flowchart of the this is going to the overall flowchart of the single bus DDM protocol. Like it starts from memory organization to read operation, write operation, and replace operation. Again the read and write are subcategorized each type. Then each type was subcategorized into number of steps. This is going to the overall flowchart for the DDM protocol. Now let us see what does mean by attraction memory protocol. Attraction memory, which we say before the cache only memory. See, you can think it of as like an extension of the cache memory to the last level of cache only memory. Like it works as it seems. First it will be an I here represents the invalid. I it represents the invalid. Invalid will be points out to the R. R represents here reading. Reading will be points out to end data. Through end data it will point out to the S. S means shade here. Here read has the self node and S has the self node, but invalid doesn't have any kind of self node here, as you can see. Given I is point out to the RW, read and write. For read and write there will be an bidirectional to end data to NRS or NRS to NRead. Even there is a self node NRS or NRead, N exclusive and read. Now see write operation. Write option is exclusive and S is given to P write or NRS. Now E will be given rise to NRead and N data, and E will have read write. This is the whole attraction memory protocol. You can see the notations which on my screen. Let me raise the screen. You can see the notations here. First it will be interaction or interaction or out transaction. P from processor, N from network, E is exclusive, I is invalid, R made by reading, RW reading and writing, S means shared, W means writing. Now let us see what does it mean by hierarchical DDM protocol. Hierarchical DDM protocol in the sense, like which we discussed, like there will be only one. Suppose if you take an like attraction memory here. Attraction memory was singly attached into the cache memory, and each cache memory was classified into the processor. There will be only one structure here. In the hierarchical structure, this is the only first we discuss. Now let us see how hierarchical will be get performed. See this is how hierarchical will be. First there will be each process. There are multiple various number of processes, like you can think of n processor. Each process will be connected into each attraction memory. You can see each attraction memory, like you can see, if you think of there were n attraction memory, then there will be n processor will be there. Now each system was connected into each DDM bus here. At top there will be a top protocol here. This is going to the whole hierarchical DDM protocol. uh, Hierarchical protocol. Directory is similar to attraction memory except that they do not store any data. Directory is similar to the attraction memory. Directory here you can see D. Directory is similar to the attraction memory except that they do not store any data. For the bus below, it behaves like a top protocol. For bus above, it behaves like an above protocol. Multi-level read and multi-level write and multi-level replacement. Now let us see what does it mean by multi-level DDM protocol. Multi-level DDM protocol, in the sense, still now we have seen various kind like single level which directly attached into the memory, and we will discuss the hierarchical, like it will be here like this multiple blocks. Now multi-level in the sense, see, let me erase the screen. Suppose take a block A, take another block B, another block C, like each were interconnected one after one after, unless like hierarchy will be like all will derive at a time from the single time. Unlike the hierarchical, multi-level will be like each block will take hierarchical into from the this kind of sequence in the line sequence, whereas hierarchical 3 take at a time from the attraction memory at a time. This is the main difference between the multi-level and the hierarchical. Yeah, you can see the main points which related to the multi DDM protocol. First, it will be directory requirements are sizes of directory I plus 1 is equal to bi into directory of I. Next, associativity of directory I plus 1 is equal to bi into dir1, where bi1 is the branching factor for level 1. Too much hierarchy will costly and slow. Could use imperfect directories. Protocol is sequentially consistent. Bandwidth requirement for this for this bandwidth requirements are fat tree network, directory bus splitting, and heterogeneous networks. Now let us see cache only memory architecture prototype. This is going to the prototype. Like prototype means in the design. You can think of a design. This is going to the design how it will going to work. The first data bus will be there. Data bus will connect to a node controller. Inside node there will be an attraction memory state. Now inside the main here interface and the memory attraction memory data, they will cache MMU. Each cache MMU is going to attach to the processor. This is going to main memory going to fetch data from the cache only memory and interface. Using this both interface here, it will be connected to the DDM bus. Again, by using this whole operations, DDM bus is going to fetch data from this whole thing, and this is the how it is going to be, fetch the data. Now let us see prototype description which we discussed earlier. For address transaction, DDM bus uses normal, virtual, and to physical address transaction mechanism. For item size equal 16 bytes, overhead is 6% of 32 processor system. Overhead it is 16% of 256 processor system. For larger item size, the overhead is lower, but phase sharing may cause problems. You can see performances of this performance on my screen. You can compare the performance by analyzing the graph for various input data. Cold data included DDM topology, high rate present data cache, attraction memory, and remote access. You can compare the each and speeds and from the data which are given here. Now let us see the graph for this table. This is going to the graph for performance of the computer cache only memory. You can compare the cache only memory with another by using the before table. This is going to the graph then. Now let us see the conclusion. COMA, cache only memory architecture, is middle ground between, like it is going to middle between the uniform memory network and NUMA, where uniform memory memory is going to be uniform memory architecture is going to be way more faster than the COMA, whereas cache only memory architecture COMA is going to be way more better than the NUMA. NUMA, non-uniform memory architecture. This is the stepwise. Like first it will be first it will be UMA, next it will be an cache only memory, next it will be an UMA. Like this is going to be get first priority. Next like if you want to consider the rankings for them. Now in the prototype overhead, 16% access time and 6% memory. Program productivity improved by worrying about NUMA issue here. This I think so I covered each and every point about the cache only memory architecture. Still now everything I compared with NUMA, UMA, cache memory prototype. I think so I discussed the like what is the time difference between this and this, and even I showed the graph. I think so I we cleared everything. Thank you. Thank you.